All right, it looks like we're live. So let's go ahead and get set up and started here. First of all, I don't have the chat open, so that'll be our first order of business. Don't need that preview. So if we put you right there, are about and let's make dark mode. All right, perfect. So assuming that chat works today, then we're all set up. So let's take a look at where we are. Good morning, Miguel. It's nice to verify that chat is working indeed. Okay, so where are we? We're currently at more about cargo and crates.io. Right, we just finished chapter 13 and now we're moving on to chapter 14. So, so far we've used only the most basic features of cargo to build, run, and test our code, but it can do a lot more. In this chapter, we'll discuss some of its other more advanced features to show you how to do the following. Customize your build through release profiles, push libraries on crates.io, organize large projects with workspaces, install binaries from crates.io, extend cargo using custom commands. Cargo can do even more than what we cover in this chapter, so for a full explanation of all of its features, see its documentation. All right, let's dive in. Customizing builds with release profiles. In Rust, release profiles are predefined and customizable profiles with different configurations that allow a programmer to have more control over various options for compiling code. Each profile is configured independently of the others. Cargo has two main profiles, the dev profile Cargo uses when you run cargo build, and the release profile Cargo uses when you run cargo build -- release. The dev profile is defined with good defaults for the development, and the release profile has good defaults for release builds. These profile names might be familiar from the output of your builds. So cargo builds and then finish dev, yeah, unoptimized plus debugging. And then cargo build -- release, finished release, optimized targets, okay. The dev and release shown in this build output indicate that the compiler is using different profiles. Cargo has different default settings for each of the profiles that apply when there aren't any profile.star sections in the project's cargo.toml file. By adding profile.star sections for any profile you want to customize, you can override any subset of the default settings. For example, here are the default values for the opt level setting for the dev and release profiles. Are we almost elite hackers in Rust yet? I suppose so. We're on chapter 14 out of what, 20 or so? Yeah, 20. 14 out of 20. So I guess that makes us close to elite level. Okay, so you can override any of the sub settings, for example, like profile.dev, opt level 0, or release opt level 3. The opt level setting controls the number of optimizations Rust will apply to your code, with a range of 0 to 3. Applying more optimizations extends compiling time, so if you're in development and compiling your code often, you'll want faster compiling even if the resulting code runs slower. That is the reason the default opt level for dev is 0. When you're ready to release your code, it's best to spend more time compiling. You only compile in release mode once, but you'll run the compiled program many times. So release mode trades longer compile time for code that runs faster. That is why the default opt level for the release profile is 3. You can override any default setting by adding a different value for it in cargo.toml. For example, if we want to use optimization level 1 in the development profile, we can add these 2 lines to our project's cargo.toml file. Profile.dev opt level 1. This code overrides the default setting of 0. Now when we run cargo build, cargo will test the defaults for the dev profile plus our customization to opt level. Because we set opt level to 1, cargo will apply more optimizations than the default, but not as many as in a release build. For the full list of configuration options and defaults for each profile, see cargo's documentation. So specifying dependency, manifest. Configuration, I guess. There are tons of things to throw in here. Environment variables. Wait, that doesn't include. There's the package, the build links. Profile. So opt level for the optimizations, debug, rpath, LTO, assertions. So yeah, there's a bunch of things to do here. Okay, so there's a profile.test opt level 0. So here we could override that potentially to like profile test release. And that would opt level 3 it. That would test to make sure that after the optimizations, everything still works exactly as it is, and we're not going to run into any weird bugs with the optimizer. Publishing a crate to crates.io. We've used packages from crates.io as dependencies of our project, but you can also share your code with other people by publishing your own packages. The crate repository at crates.io distributes the source code of your packages, so it primarily hosts code that is open source. Rust and Cargo have features that help make your published package easier for people to use and to find in the first place. We'll talk about some of these features next, and then explain how to publish a package. Making useful documentation comments. Accurately documenting your packages will help other users know how and when to use them. So it's worth investing the time to write documentation. In Chapter 3, we discussed how to comment Rust's code using 2 slashes. Rust also has a particular kind of comment for documentation, known conveniently as documentation comment, that will generate HTML documentation. The HTML displays the contents of documentation comments for public API items intended for programmers interested in knowing how to use your crate, as opposed to how your crate is implemented. Documentation comments use 3 slashes instead of 2 and support markdown notation for formatting the text. Place documentation comments just before the item they're documenting. Listing 14.1 shows documentation comments for an add one function in a crate named myCrate. Okay, so it's just markdown. This reminds me of like the Python documentation comments that are used in functions that like auto-generate those the documentation that you can use inside the language, inside the REPL to sort of play around with other libraries. Here we give a description of what the add one function does. Start a section with the heading, examples, and then provide code that demonstrates how to use the add1 function. We can generate the HTML documentation from this documentation comment by running cargo doc. This command runs the Rust doc tool distributed with Rust and puts the generated HTML documentation in the target doc directory. For convenience, running cargo doc open will build the HTML for your current crates documentation, as well as the documentation for all of your crates dependencies, and open the result in a web browser. Navigate to the add1 function, and you'll see how the text in the documentation comments is rendered, as shown in figure 14.1. I wonder what will happen if I do that without having written any of these comments. So let's cd projects mine, learning Rust. Let's go to chapter 12, the mini grep. And let's just generate this document, the docs here. So cargo, what is it, just doc? Cargo doc, dash open. Okay, so it's just gonna pull the docs for the lives. It actually looks like it created docs for mine too, which specifically, I can now see what the functions are in the module grep that I created. And set it up. So like it has everything here, including like looking at what the source code is. So even if I don't have the actual comments in there, it actually is really interesting. It actually can be very useful, because this is the stuff that doesn't lie, whereas the comments might. So I like that. This is really nice. Run doesn't really tell me, these don't tell me too much, but they just show the code and what it looks like. Commonly used sections. We used the examples markdown heading in listing 14.1 to create a section in the HTML with the title examples. Here are some other sections that crate authors commonly use in their documentation. Panics. The scenarios in which the function being documented could panic. Callers of the function who don't want their programs to panic should make sure they don't call the function in these situations. Errors. If the function returns a result, describing the kinds of errors that might occur and what conditions might cause those errors to be returned can be helpful to callers, so they can write code to handle the different kinds of errors in different ways. Safety. If the function is unsafe to call, we discuss safety in chapter 19, there should be a section explaining why the function is unsafe and covering the invariants that the function expects callers to uphold. Most documentation comments don't need all these sections, but this is a good checklist to remind you of the aspects of your code that people calling your code will be interested in knowing about. I always wondered what the auto trait send and receive that always comes up in docs. The auto trait send and receive, is that in here? I don't think there's... Actually, do we even use anything that has traits in here? I don't think so. Oh, auto trait implementations. Implement send for config, implement sync for config. So this is just in struct minigrep grep config. So it auto added send and sync for these for config, which is really interesting. So I could go to send And this takes me to the real documentation. It took me to the internet, so it would be the most updated one. I notice it's also nightly. Am I running with nightly right here? Rust up -v. No, that doesn't help me. Show. It's rest up show. Okay, so I've got stable and I've got nightly installed. Active tool chains, stable. Okay, so I'm on stable, but it brought me to the nightly documentation, which is really interesting because I suppose if they change this, I wouldn't notice that. I would have to know what the version number that I'm caring about is, and I don't necessarily memorize those. Types that can be, okay. Types that can be transferred across thread boundaries. This trait is automatically implemented when the compiler determines it's appropriate. An example of nonsense type is the reference counting pointer. If two thread, okay, so this is what they're doing for thread safety. If they decide to send it to a thread, it can then get from a thread too. Of course, I'm not using that, I guess. I mean, I don't think I'm using that, but it is interesting. Documentation comments as tests. Adding example code blocks in your documentation comments can help demonstrate how to use your library, and doing so has an additional bonus. Running cargo test will run the code examples in your documentation as tests. Nothing is better than documentation with examples, but nothing is worse than examples that don't work because the code has changed since the documentation was written. If we run cargo test with the documentation for the add one function from listing 14.1, we will see a section in the test result like this. Doc tests, my crate, running one test. So wait a second, what does this look like? Assert equal. So we could totally do that. Let's actually add a little bit of documentation here. Let's open up code. Okay, so in librs, what do we care about? What's one of the tests we have here? We have config tests, mod test, use super, search case insensitive. I wonder, like, do I put it here? Probably not, but I'm guessing that the comments in here won't be added in. So do I even need these tests here? Would I want to put all the tests inside of the documentation code? Like, for example, if I take this and I let's copy this, comment out you, and this is search case insensitive. So public function search case insensitive. So 1, 2, 3, and we'll just say search case sensitive. And what else did they have here? It's just then they had the document right here. So we could do something like allows caller to search through a string or while ignoring case. Will get back. Well, I guess like I don't necessarily need to say what it will get back, because I could then run this. This is going to be Rust. I wonder if that's, probably don't need to care about that. We'll paste you. I do. Yeah, I don't like that. Boom. Okay, and then assert equal is also part of this too. And I think you are part of this as well. There. Okay, so this should be the documentation for search case insensitive. Let's go ahead and rebuild this. So cargo test. Okay, doc test mini grep. It did fail on this. Use of undeclared type or module grep. So we ran into this problem because it couldn't find right here. So assert equal grep. Maybe it should just be this. We run search case insensitive. We pass it in the query. So maybe I want to move you down. I probably don't need these functions, do I? Okay, so if we do that, let content equals this. Then we have let query equals this. And then finally the assert. So we have the query, we have the content, and then we check to see if we get this vector back. Save and try again. Okay, so failed again. Assert equal, not found in this scope. Search case insensitive. So it's right here. Why can't we see it? I know that, like, I have this inside of public mod grep, but it didn't like that either. Public function add one. My crate add one. Okay, so do I need to do it as a crate? So what is this called? Just mini grep, I think. That? Which mini grep that. Let's try that. Okay, so that also failed. Panicked at text executable failed. Okay, so it ran this time. Left had this weird space. safe, fast, productive. Right had safe, fast, productive with no space. So the left-hand side, which is the query. Okay, so this is what we got out of it. Whereas the vector, safe, fast, productive. Oh, interesting. So is it because we don't have weird... Oh, it's this. We need to bring it down like that. Okay. Try you. Okay, so all the tests passed. So now we should be able to do cargo docs open. And let's see what this documentation looks like. So in the create mini grep, which is just this, we have grep. We have search case insensitive, which has this, has the title here. If we come in, it shows us how it works. Allows the caller to search through a string while ignoring the case, and then also shows us the implementation of it and the documentation code right here. So that's actually pretty cool that we can use, we can just put the real tests in here completely. Also something really interesting is that it spaces these in. So I'm used to like putting spaces next to the slashes. That won't work for like certain examples. So that's interesting to know. But yeah, now I can put the code in here. I could put like actual tests in here. The only problem is I don't get good syntax highlighting. Okay, so we got documentation, comments as tests. Now if we change either the function or the example so that the assert equal in the example panics and run cargo test again, we'll see that the doc tests catch that the example and the code are out of sync with each other. I would say using test would be kind of a niche thing. Probably. Commenting contained items. Another style of doc comment, so / bang, adds documentation to the item that contains the comments rather than adding documentation to the items following the comments. We typically use these doc comments inside the create root file, so source librs, by convention, or inside a module to document the crate or the module as a whole. For example, if we want to add documentation that describes the purpose of the myCrate crate that contains the add one function, we can add documentation comments that start with / bang, the beginning of the source librs file as shown in listing 14.2. So / bang, myCrate is a collection of utilities. So basically this surrounds the other comments that we'll have. Notice there isn't any code after the last line that begins with / bang. Because we started the comments with / bang instead of //, we're documenting the item that contains this comment rather than the item that follows this comment. In this case, the item that contains this comment is the source librs file, which is the crate root. These comments describe the entire crate. When we run cargo doc open, these comments will display on the front page of the documentation for my crate, above the list of public items in the crate as shown in 14.2. Okay, so it shows up for the create my crate. So that's what we see then. Documentation comments within items are useful for describing crates and modules especially. Use them to explain the overall purpose of the container to help your users understand the crate's organization. Exporting a convenient public API with pub/use. In Chapter 7, we covered how to organize our code into modules using the mod keyword, how to make items public using the pub keyword, and how to bring items into a scope with the use keyword. However, the structure that makes sense to you while you're developing a crate might not be very convenient for your users. You might want to organize your structs in a hierarchy containing multiple levels, but then people who want to use a type you've defined deep in the hierarchy might have trouble finding out that type exists. They might also be annoyed at having to enter use myCrate some module, another module, useful type, rather than use myCrate useful type. The structure of your public API is a major consideration when publishing a crate. People who use your crate are less familiar with the structure than you are, and might have difficulty finding the pieces they want to use if your crate has a large module hierarchy. The good news is that if the structure isn't convenient for others to use from another library, you don't have to rearrange your internal organization. Instead, you can re-export items to make a public structure that's different from your private structure by using pub/use. Re-exporting takes a public item in one location and makes it public in another location, as if it were defined in the other location instead. For example, say we made a library named Art for modeling artistic concepts. Within this library are two modules: a kinds module containing two enums named primary color and secondary color, and a utils module containing a function named mix, as shown in listing 14.3. So pubmod kinds, and inside there's an enum primary color. Okay. Figure 14.3 shows what the front page of the documentation for this crate generated by Cargo Doc would look like. So yeah, it doesn't have any of those types in here. You'd have to dive down to find them. Note that the primary color and secondary color types aren't listed on the front page, nor is the mix function. We have to click kinds and utils to see them. Another crate that depends on this library would need use statements that import the items from Art. Specifying the module structure that's currently defined, listing 14.4 shows an example of a crate that uses the primary color and mix items from the Art crate. So use Art kinds primary color. Yeah, that's kind of annoying. The author of the code in listing 14.4, which uses the Art crate, had to figure out that the primary color is in the kinds module and mix is in the utils module. The module structure of the Art crate is more relevant to developers working on the Art crate than to developers using the Art crate. The internal structure that organizes parts of the crate into the kinds module and the utils module doesn't contain any useful information for someone trying to understand how to use the Art crate. Instead, the Art crate's module structure causes confusion because developers have to figure out where to look, and the structure is inconvenient because developers must specify the module names in the use statements. To remove the internal organization from the public API, we can modify the Art crate code in listing 14.3 to add pub/use statements to re-export the items at the top level, as shown in listing 14.5. Okay, so we have this Art create a library for modeling artistic concepts, pub/use kinds primary color. So I think that I can do this in here because we sort of made the mistake of making a grep module at the top level when we didn't necessarily need to, and configs is a struct in there. So maybe what I could do is we'll first start by these type of documentation styles, and we'll say minigrep minigrep a crate for searching files, and then pub/use I guess it'll be grep config, like that. So if we save, open up the documentation again, re-exports pub use grep config. So now I can come here and see where it comes from. That's nice. The API documentation that Cargo doc generates for this crate will now list and link re-exports on the front page, as shown in 14.14, making the primary color and secondary color types and the mix function easier to find. Yeah. The art crate users can still see and use the internal structure from listing 14.3 as demonstrated in listing 14.4, or they can use the more convenient structure in listing 14.5 as shown in listing 14.6. Yeah, they could basically use that now. In cases where there are many nested modules, re-exporting the types at the top level with pub use can make a significant difference in the experience of people who use the crate. Creating a useful public API structure is more of an art than a science, and you can iterate to find the API that works best for your users. Choosing pub use gives you flexibility in how you structure your crate internally and decouples that internal structure from what you present to your users. Look at some of the code of crates you've installed to see if their internal structure differs from their public API. Well, also I can see it from their documentation because it would say re-exported. Setting up a Crates.io account. Before you can publish any crates, you need to create an account on Crates.io and get an API token. To do so, visit the homepage at Crates.io and log in via a GitHub account. The GitHub account is currently a requirement, but the site might support other ways of creating an account in the future. Once you've logged in, visit your account settings at Crates.io me and retrieve your API key. Then run the Kroger login command with your API key like this. So I'm not going to do this. I'm not going to do this right now. Plus, I don't really have any crates that I want to publish at this time. This command will inform Cargo of your API token and store it locally in Cargo credentials. Note that this token is a secret. Do not share it with anyone else. If you do share it with anyone for any reason, you should revoke it and generate a new token on Crates.io. Definitely. Not a good idea to like accidentally push that up to GitHub or something. Adding metadata to the new crate. Now that you have an account, let's say you have a crate you want to publish. Before publishing, you'll need to add some metadata to your crate by adding it to the package section of the crate's cargo.toml file. Your crate will need a unique name. While you're working on a crate locally, you can name a crate whatever you'd like. However, crate names on Crates.io are allocated on a first-come, first-served basis. Once a crate name is taken, no one else can publish a crate with that name. Search for the name you want to use on the site to find out whether it has been used. If it hasn't, edit the name in a cargo toml file under package to use the name for publishing, like so. So package name guessing. Even if you've chosen a unique name, when you run cargo publish to publish the crate at this point, you'll get a warning and then an error. So warning, manifest has no description, license file documentation, homepage, or repository. Error, missing or empty metadata fields, description, or license. The reason is that you're missing some crucial information. A description and license are required so people know what your crate does and under what terms they can use it. To rectify this error, you need to include this information in the cargo.toml file. Add a description that is just a sentence or two, because it will appear with your crate in search results. For the license field, you need to give a license identifier value. The Linux Foundation Software Package Data Exchange lists the identifiers you can use for this value. For example, to specify that you've licensed your crate using the MIT license, add the MIT identifier. So MIT has sort of become the go-to license that a lot of web developers use because it's just like allows for the sharing of everything. Plus, your source code for front-end stuff has to be open source regardless. Could be worse, you could push your AWS token to GitHub. I know people who've done that. In fact, I've had students do that before, and then things get bad. AWS has gotten a little bit better at refunding when you do that, but they still don't still not recommended that you allow it to happen. If you want to use a license that doesn't appear in the SPDX, you need to place the text of that license in a file, include the file in your project, and use license file to specify the name of that file instead of using the license key. Guidance on which license is appropriate for your project is beyond the scope of this book. Many people in the Rust community license their projects in the same way as Rust as by using a dual license of MIT or Apache 2.0. This practice demonstrates that you can also specify multiple license identifiers separated by OR to have multiple licenses for your project. So that sounds really weird because licenses are kind of contracts. I don't know enough about the Apache 2.0 license to know if there's anything that does it, what if you put in two licenses that contradict with you? With a unique name, the version and author details that Cargo new added when you create the crate, your description, and a license added, the cargo.toml file for a project that is ready to publish might look like this. Okay, Cargo's documentation describes other metadata you can specify to ensure others can discover and use your crate more easily. Publishing to Crates.io. Now that you've created an account, saved your API token, chosen a name for your crate, and specified the required metadata, you're ready to publish. Publishing a crate uploads a specific version to Crates.io for others to use. Be careful when publishing a crate, because a publish is permanent. The version can never be overwritten, and code cannot be deleted. One major goal of Crates.io is to act as a permanent archive of code, so that builds all of the projects and depends on crates from Crates.io will continue to work. Allowing version deletions would make fulfilling that goal impossible. However, there is no limit to the number of crate versions you can publish. Run the cargo publish command again, it should succeed now. So npm ran into that problem with a variety of crates modules because of various political things that happened, and then people pulled out and said, well, I no longer give you permission to release my code, and npm deleted it, and then problems happened when so many people depended upon those libraries. So it sounds like they don't have the same problem with here, but it sounds like they do have the namespace problem. It might be interesting to see when we do like a crate install, is there like a script that gets run? It's getting near 8 a.m., so you know what that means. I know, 17 minutes left till 8. Congratulations, you've now shared your code with the Rust community, and anyone can easily add your crate as a dependency of their project. Publishing a new version of an existing crate. Oh, you're talking about drop frames. Yep, and looking at that, drop frames 117.1%. So not very much, but it's I think also Wimbledon is starting now, and they're over in Europe too, so everybody is waking up early to watch that as well. So too many sports things are happening early in the morning. It's making it so I can't stream. People in your community are hell-bent on using the internet at 8 a.m. I know, they want to watch tennis and, and football, like European football. So, I don't know, besides to tell them not to do that. They could watch my stream. I'm more interesting, right? When you made changes to your crate and are ready to release a new version, you change the version value specified in your cargo.toml file and republish. Use the semantic versioning rules to decide what an appropriate next version number is based on the kinds of changes you've made. Then run cargo publish to upload the new version. I was kind of hoping they had auto versioning. for that. Mainly because people can now accidentally choose the wrong like patch, minor, or major version and give just not use it correctly. Removing versions from crates.io with cargo yank. Although you can't remove previous versions of a crate, you can prevent any future projects from adding them as a new dependency. This is useful when a crate version is broken for one reason or another. In such situations, Cargo supports yanking a crate version. Yanking a version prevents new projects from starting to depend on that version while allowing all existing projects that depend on it to continue to download and depend on that version. Essentially, a yank means that all projects with a cargo.lock will not break, and any future cargo.lock files generated will not use the yanked version. Interesting. So basically you can't remove the code, but you can deprecate it essentially. To yank a version of a crate, run cargo yank and specify which version you want to yank. By adding undo to the command, you can also undo a yank and allow projects to start depending on a version again. A yank does not delete any code. For example, the yank feature is not intended for deleting accidentally uploaded secrets. If that happens, you must reset those secrets immediately. Cargo workspaces. In Chapter 12, we built a package that included a binary crate and a library crate. As your project develops, you might find that the library crate continues to get bigger, and you want to split up your package further into multiple library crates. In this situation, Cargo offers a feature called Workspaces that can help manage multiple related packages that are developed in tandem. Creating a workspace. A workspace is a set of packages that share the same cargo.lock and output directory. Let's make a project using a workspace. We'll use trivial code so we can concentrate on the structure of the workspace. There are multiple ways to structure a workspace. We're going to show one common way. We'll have a workspace containing a binary and two libraries. The binary, which will provide the main functionality, will depend on the two libraries. One library will provide an add1 function and a second library an add2 function. These three crates will be part of the same workspace. We'll start by creating a new directory for the workspace. Interesting. So we create the directory ourselves. Let's go and do this. First of all, we'll close you. So we're in chapter 14, right? So take chapter 14. Let's just do that in here. Well, we'll do this here. So take add. Next, in the add directory, create the cargo.toml file that will configure the entire workspace. This file won't have a package section or the metadata we've seen in other cargo.toml files. Instead, it will start with a workspace section that will allow us to add members to the workspace by specifying the path to our binary crate. In this case, that path is adder. So they're having us like manually create this file. Is cargo-h. Is there a way to do like a new workspace? There's new. Let's see. So version list. I think this. Okay. Build check clean doc new init. Okay, I'm not seeing that there. I could do cargo help command. So cargo help new. Okay, so initialize new repository for the given version control system. Use a binary, use a library template, set the name. Okay, so apparently no, we have to create that ourselves. So touch, what does this need? Cargo.toml. I think you have to legit just touch the file. And what are they having us put in here? Well, they're also having us put in here like this, workspace members. Right, next in the add directory, we create this file. The file won't have a package section. Instead, it'll start with a workspace section that allows us to add members to the workspace by specifying the path to our binary crate. In this case, that path is adder. So we have a workspace. And members adder. Interesting that it looks exactly like this. So I don't need to search for marketplace stuff. Next, we'll create the adder binary crate by running cargo new within the add directory. So cargo new adder. That creates the binary application adder. At this point, we can build the workspace by running cargo build. The files in your add directory should look like this. Okay, yeah, it does look like that. Yeah. Wait, is there no... Oh, no, there is a cargo toml in here as well. But so can I do cargo run? Error manifest path is a virtual manifest, but this command requires running against an actual package in this workspace. So it is aware that we're in a workspace. It just doesn't know what to do. The workspace has one target directory at the top level for the compiled artifacts to be placed into. The adder crate doesn't have its own target directory. Even if we were to run cargo build from inside the adder directory, the compiled artifacts would still end up in add target rather than add adder target. Cargo structures the target directory in a workspace like this because crates in a workspace are meant to depend on each other. Wait, so at this point we can build the workspace by running cargo build. So cargo build. Okay, so that runs that. Cargo structures the target directory in a workspace like this because the crates in workspace are meant to depend on each other. If each crate has its own target directory, each crate would have to recompile each of the other crates in the workspace to have the artifacts in its own target directory. By sharing one target directory, the crates can avoid unnecessary rebuilding. All right. I'm wondering, like, if there is a way to like build everything all at once, but I guess we have to go into the binary crate in order to run it specifically. But that will be tomorrow morning because it is after 7:50. We haven't had any more drop frames than that 117 we got earlier, but I'm gonna quit before we get, press our luck too much. Let's go ahead and update where we're at. So we'll update our README. Currently at here. All right, so we got all of that. Let's go ahead and check to see what code we've got. So updated where we are at. These are LibRS for chapter 12. Added documentation comments. And then these, cargo de tamel. The rest of you are playing with workspaces. And send them on up. I've got the links to the code in the stream description and also in the YouTube video description. I don't think I really have anything else to do, so thank you everybody for stopping by. Maybe it's because I'm tired, but I didn't notice any frame dropping. It wasn't very many frames, so it probably was just like a really tiny blip. And I don't know exactly what it is because OBS by default doesn't have like a histogram up, and I think I could go and like find out exactly when it happened, but it's not happening right now. So there's that. Anyways, I'm doing these learning Rust videos every single weekday morning at 7 a.m. Mountain Time. We're currently in the middle of chapter 14 of 20 chapters. So we are reaching the latter half, the latter 3/4 of the book. It's getting really exciting because after the book is done, we're going to be creating some things with Rust, and that'll be fun as well. I have a Twitter account that I send out tweets usually right before I stream, or right like at the beginning of it. You can either follow me there or just subscribe to each of my channels to get notifications when I go live. With that, I don't think I have any other announcements or anything else, so I'm going to go get ready for the rest of my day, and I hope you have a great rest of yours, and I'll see you all tomorrow.